Hello again, everybody. This is Joseph with a tutorial and explanation of how to understand schematic diagrams. I'm often asked by people how to understand and how to figure out the application and the purpose of each component in a schematic. And it's not easy, it's very difficult many times. But you always start with the basics of how a component acts and its purpose and its application. Now, first, obviously, like a roadmap, you always have to understand the symbols first before you ever begin understanding the schematic. Now, to try to make something to simplify it, these are basics symbols that we use today in modern schematics. Some we use, some we don't use. However, the theory is the same. So we always begin, like I said, with the foundation of the components and the symbols and understanding them. First of all, like I had many emails, people tell me, even though I read the schematic, I really don't comprehend what the application of the circuit is, what it's trying to do. Well, that's because some components have different applications, and I'll explain and I'll elaborate what I mean on that. First of all, let's start with the fundamentals. Components like resistors, like capacitors. Now, as you see, there's two plates, and in between them there could be air. So a capacitor, to make it, try to simplify it, just like a resistor, which limits the amount of current going through it. That's what a resistor does. A capacitor can hold the charge. It can allow AC to go through and can block DC. But first, before that, we always have to pay attention to look for things. We know, like in batteries, I have another channel called Automotive, Electronic Schematics by Joseph, about diagnostics and many schematics. The schematics deal with resistors and other things, and what we're looking for is, sometimes you have polarity. You have to pay attention to things that have polarity. What I mean by polarity, a positive sign and a negative sign, such as the source. In automotive, obviously, we're talking about the battery being the source. So therefore, always pay attention. If one side of a component is positive, we have to make sure that that side is obviously connected properly. Where you don't see any polarity like this one, that means you could connect it any way you want. Either this side of the component can go to a resistor, or this side could go to a resistor. Now, when we want to put this side, we have to pay attention to the positive side. Let's say we'll go to a battery source. The positive will go to the positive. We have to pay attention, whatever the diagram tells us to do. There's only one side that you're allowed to connect the positive. The other thing is, pay attention to the arrows. These arrows, as I said in my previous explanations or tutorials, I guess, there's a few things that can happen with components. They can have a set value. This is a set value. How do I know that? Because there's no arrow going through it. Now, let's say this is 10 microfarads. This is 10 microfarads. This can go up to 10 microfarads, but it can go even less than that. So a fixed resistor also has a set amount, has a value in it. Let's say it's 100 ohm, and that's it. It stays 100 ohm. It's not 50 ohms. It's not 30 ohms. It's not 1,000 ohms. It is 100 ohms. How will you know? It'll say 100 ohm, 100 underneath it. The point I'm getting to is, you have to pay attention to the arrows. Those are telling you it is a variable. Variable means it can be changed. The value of it can be changed. And why do we need that? Because we want to change the value sometimes of that component, like in the radio, in AM, and FM, so you're able to get the station. We don't want so many components with different values. Otherwise, our circuit boards would be tremendous, would be huge, just with all the components that we need. We want to shrink the PC board as much as we can. That's how we have a cell phone. We shrunk the PC boards. That's how we have flat screen TVs. We shrunk the PC boards. We put less components. That means you can make the TV or the radio smaller, or the cell phone smaller. That's what we want. Anyway, let's say a fixed resistor. Let's equivalent it to, let's say, a quarter. A quarter is set at 25 cents. It cannot be a dime. It cannot be 10 cents. It cannot be a nickel, 5 cents. It is, quarter is 25 cents. So a fixed resistor is, let's say, 25 ohms. A variable resistor, as I always give an example, let's say you have a credit card. Limit is up to $10,000. That means I can use it for $5,000, $500, $300, up to $10,000. Let's say this variable resistor, and the middle one over here is called the wiper. The middle one over here, actually, this is used for a voltage. We use the middle one for a voltage. We split the voltage. However, there is another one where we have a connection from one side here going back to here, and that's called the rheostat, where we can change the value. And in other words, we could go 10,000 ohms, 500 ohms, 200 ohms, whatever, as application is needed. We can change the value, just like a credit card. We can use whatever we need. So again, pay attention to these. These are very important. This means you have a capacitor that changes value, and that's what the circuit demands. This means no, one value, one value, one value. Whatever the value is, it'll say right next to it, that value. Fixed, but polarized. Polarized means positive and negative. Always pay attention to that. A transformer, we know, it gives us AC. Obviously, we need transformers to bring AC to our house. But in electronics, besides electrical, we always need it to step up the voltage or step down the voltage. One is called the primary, and there are many turns of wires, the thousands and thousands, on one side, and the other one, many turns, much more turns than the first one. It's called the secondary. And you'll see transformers all over. So these are important symbols to know. These also are important symbols to know. But the transistors came, but the grandfather of them all was the diode. The diode came, actually before that came the vacuum tube. Then the diode came out as a semiconductor, it was called, meaning it could conduct it one way, but its block does not conduct in the other way. So therefore, if it's conventional current you're going with, or electron current, so current can flow one way, but it won't go the other way, like a one-way street. I always say, traffic can go on a one-way street, but it can't go the other way. Now we a little upgraded it, and we said, you know what? Voltages change according to load conditions. Just like in the generator, your alternator, you have something called a regulator. Well, upon the need or demand of accessories that you use, let's say the radios, the lights, the demand will change. The voltage we try to regulate to keep the same, regardless of how many accessories we put on. We do not want the voltage to change to 12 volts, 14 volts, 16 volts, 18 volts. No, we want it to remain. And usually it's around, the alternator with the regulator is around 13.6 to 14. And I made the videos about that. Regulate to keep constant. So therefore, as you can see, the symbol over here is a little different than this. This is called the cathode. This is called the anode. This is a little, see this bend over here gives us the idea that obviously this is called a Zener diode, different than this one. And it is to like we said, to regulate the voltage, to keep it constant. And it is very, very popular and needed. So you have to understand these. Always know these symbols, and we'll go through all how they work. But this is just to familiarize you with the symbols when you see them. Of course, there are other ones. These other ones, SCRs and Triac and all these are not used that much except in high current applications. You will not see this too much. This is for AC, depending how much of a sine wave you're using. Sometimes you want to turn on a light 90 degrees, 180 degrees, half of the time. You do not see these too much. You have to concentrate on this one. After concentrate on this one, you'll see this. You have to concentrate on bridge rectifier. After this AC, you want to change it to DC. Going back to our example of the alternator in your car is an AC generator. It gives out AC, but the battery does not need AC to replenish it, to recharge it. It needs DC. So therefore, we have something, 4 diodes connected in this way, in here. A diode here, a diode here, a diode here, a diode here. Now there are silicon diodes, there are germanium diodes. Most of the time we use silicon, and the voltage drop across it is about 0.6 volts, 0.6 when it conducts. So in other words, you could think of it like a short circuit because it has low ohms, and the other direction it is high ohms. It does not let current go through. As we said, we'll go through all these things later on. However, bridge rectifier, you have to know these symbols. If you see a transformer and you're getting DC out, that means somehow a bridge rectifier was involved in that process. The other ones I always talk about, these transistors are very important. These are the fundamentals of electronics. And I made so many videos about Ohm's law and NPN and these type of transistors, the configuration, common emitter, common collector. I made so many of them. Anyway, the symbol for, there are 3 connections. The base, the collector, the emitter. When we get this junction to conduct, then current can conduct through the collector, through the emitter. First, we have to get this one going. Now, this is a P junction over here. That means this has to be more, the base has to be more positive than the emitter by 0.6 volts. This one going in means it's an N channel at the base. That means that the base has to be more negative by 0.6 volts than the emitter. If this is 1 volt, this has to be 0.4 volts. If this is 1 volt, this has to be 0.4 volts. Notice the positive, notice the negative. Again, these are not used that much. I'll go through them through another time, another video. These can be used as switches in digital, on and off, or the application can be used as amplifiers to amplify a signal. As you have common emitter, like I said, so many videos I made about those. And to get to these things, photo. Photo means light striking an object, a component. LED, we're all familiar with LEDs. They are all over. In your car, warning lights, the back, the mount on your window, they're all over. Everything now is LEDs, obviously. The fact that you see arrows going out, being emitted out, means that this component is giving light out. So you know when this lights, which is like a diode, same symbol, except for the 2 arrows, meaning that light is coming out from this component. When current goes through it, it lights, either red, green, obviously, if you see so many of them. Usually green means power is on. Red means there's a problem. So, that means light is coming out from it when current is flowing through it. Now, you know, look at the difference. Again, this is called the anode, this is called the cathode. Nothing changes between that. But what does change, the photodiode means light is striking it. That means it will conduct where light hits it. So therefore, if I take an object which has light and I flash on it, it will make it conduct. This means that it will give off light. This means it needs light to conduct. Phototransistor, again, you see the arrows going in. That means it needs light to make it conduct. Same principle as this. We need this light to make it conduct. We need this light to make this transistor to turn it from an off condition to an on condition. And like I said, I'll make more videos on explaining them in applications. A solar cell, like a battery, positive, negative. Remember I said pay attention to polarity. Again, look at the light, look at the arrows. That means something is striking it. Light is striking it. Solar cells are all over now. They're used in homes to give light all over. That means light is striking it. We'll get a voltage. If we get a voltage, we get a current. Again, this type of LCR, a light is striking it. That means it will conduct where light is striking it. This again, two things to understand. Remember we talked about this little arrow? That means it is a variable. It changes. The resistance of it changes. How does it change? Where light is striking it. Look at the two arrows coming in. Light is striking it. It will conduct. Photoresistor. That means light will strike it. It will become a resistor. It will have some value of a resistor, and it will conduct. How much will it conduct? Depends how much the light. The more the intensity of the light, the more the resistors. The less light striking it, the less resistors. Now, we came to the video that I made about logic gates. This is the fundamentals of digital, and you have to know these symbols. Remember these symbols. These symbols are used everywhere. No exceptions. If you want to know digital, you must know something called the truth table, which I made so many videos. And you must know the inputs, the outputs. When the outputs are, there's something called highs and lows, ones and zeros. You have to know these things. And I made so many videos. You can refer to those videos. But remember these. This is a bubble. This means this is a low coming out. This is a low coming out. This is a low coming out. In order for this to be a 0, this will be a 1. And when you look at these, this is a 1. That means either one of these has to be a 1 for this to be a 1. And I made the videos to explain it to you. Now, to go to something else, something called switches, and this will be my final thing. The world of electronics or electricity would not exist without something called a switch. Switch is the most essential, but it is the most important thing of a circuit. Think about it. We have switches in our houses to put on the lights. Think about it. If you didn't have a switch and you always had the light in your house on all the time, how much would your electric bill be? Right? Therefore, we want to turn off the lights. But on the other hand, we want to turn on the lights also. Well, switches are the most important things sometimes in a circuit. In your car, you turn on the lights. Everything is controlled by switches. So you have to know the symbols. When something is open, when the switch is open, current cannot conduct. This has to be closed. And what I mean by closed, look at this. Look at the difference. Open, mechanically wise, closed. When it closes, then current can flow. Then you can have the lights in your house on. How do I turn off my lights? Boom, I go to the switch. And when I go to the switch, what happens? It opens mechanically. Then no current can flow. Now there are different types of switches. single pole, double throw. Let's say you have two lights in your hallway. You want to control two lights from your hall. You can have this set up where, as you see this dotted line, that means when this is closed in this position, when that's closed over here, when this is closed, when I mean closed, I mean this way, that means simultaneously this will also be closed. I call it the Siamese twins. When one moves, the other moves, right? When one opens, the other opens. When the other one is closed, the other one is closed. So therefore, this will be closed, this will be closed. It gives us two circuits. So you can close both sides, both lights of your hallway. Again, now this one, same thing. Double pole, double throw. Look at the difference. Look at the difference. Now, the same thing over here. You see this dotted line? That means that when this moves, this will move. Let's say this goes from this position. This will go to this position. A, B, C, D. This is now in this position. Here's the arrow. Here's the arrow. Now current will flow this way. Now current will flow this way. So, related to the application that you need, the switches will close two circuits, or even more, or open two circuits. And these are the fundamental. You have to know switches. They are in automotive all over. I hope this was helpful, and please subscribe to my two channels, Joe Electronic Schematics, as you know, for about transistors and things like that, and my other one, Automotive Electronic Schematics by Joseph. You have many videos to go over. Like I said, I've been asked a lot of times about how to understand schematics, and I hope this will help. Thanks for watching, everybody.